Auzubillahi minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Oladimeji Tihe, the SS3 physics teacher of CTY Model College, Ibadan, Oyo State, Nigeria. I'm welcoming you to week 4 of our e-learning class for physics, third term, SS3 2019-2020 academic session. And the topic of discussion for this week is going to be energy quantization and duality of matter. Energy quantization and duality of matter. And under this topic, we are going to consider the following subtopics: energy level in atom, ground state and excited state, emission of light energy on return to ground state, photoelectric emission, Einstein photoelectric equation and its explanation, X-ray production, characteristics and properties of X-ray, uses of X-ray, duality of matter and waves. So let's begin. Energy level in atom. Energy level in atom. Electrons in atoms exist in certain energy levels. They can jump from one energy level to another by gaining or losing energy, but they are not allowed any energy that lies in between the two energy levels. The electron can only accept or lose certain definite amount of energy. In other words, we say the energy is quantized. The energy is quantized, it's discrete, it is not continuous. There are certain allowed energy levels that the electrons can occupy. So they are not allowed to be in between the allowed energy levels. So we say the energy is quantized, as shown in the diagram. The lines represent different energy levels the electrons can occupy from E0 to E6. E0 means the lowest energy level the electron can occupy, followed by E1, E2, E3, and so on and so forth. So the electron can jump from one energy level to another one. For example, a jump from E2 to E1, that is from a higher energy level to a lower energy level, results in an emission of photon in form of photon energy radiation. And that energy radiation is given by the difference between the two energy levels, that is higher energy level minus lower energy level. And the quantum of energy radiated is given by the equation HF, which is where H is the Planck constant and F is the frequency of radiation. Therefore, the energy emitted when an electron jumps from a higher energy level to a lower energy level is given by the equation HF, that is the product of the Planck constant minus the frequency of radiation. Also, if an electron jumps from an energy level, let's say E5 to E1, that will also result in an emission of photon 2, which is also given by HF equals E5 minus E2, because it jumped from E5 to E2. But for an electron to move from a lower energy level to a higher energy level, for example, let's say from E2 to E3, that electron will need to absorb photon of energy. That is, an absorption of energy is needed for an electron to move from a lower energy level to a higher energy level. It is customary for electrons to occupy the lowest energy level before filling the higher energy levels. When every electron in an atom is in the lowest energy state available in an atom, the atom is said to be in its ground state. That is, ground state is the lowest energy level that can be occupied by an electron in an atom. However, when any of the electrons in the atom is in any of the energy level higher than the occupied energy level, the atom is said to be in the excited state. An excited state is an energy level which is higher than what the electron can occupy. So if an electron is in an energy level which is higher than what it can occupy, then we say the electron is in an excited state. Notice, an atom is to be in the excited state if any of its electron is in a higher energy level where there is a possibility of the electron returning to its normal energy state. The atom becomes ionized if the electron is so far away that it can no longer express the attraction of its nucleus. The discontinuous jump of electron from one energy level to another involves the absorption or emission of energy. These energies are better studied and measured when recorded in the spectrograph, that is, a spectrum for virtual observation. Notice, spectrum simply means an array of entity in order of increasing or decreasing magnitude. This spectra of light can be grouped into two: emission spectra and absorption spectra. So let's look at them one by one. Emission spectra. These are obtained when light from a luminous source are dispersed. There are three types of emission spectra. Light spectra, which consist of distinct and separate bright lines of definite wavelength. They are produced by gas or vapor at low pressure. Band spectra. This consists of many distinct groups or bands of line which are very close together and at one side of the band. They are obtained from molecules of glowing gases or vapor and by discharge tubes. The third type of light spectra is continuous spectra. These are produced by solid and liquids or by gases at high pressure. It can be produced by the filament of electric lamp. Now let's look at the second type of spectra, which is absorption spectra. These are produced when part of the radiation emitted by a source is absorbed by a material which is placed between the source of radiation and the observer. When light from a source having a continuous spectra is passed through a gas, e.g., sodium vapor or sodium flame, and the spectrum is observed, it is found that it is going to have dark lines in the position corresponding to the bright line in the emission spectra. Kirchhoff explained this phenomenon by stating this law: a substance which emits light of a certain wavelength at a given temperature will also absorb light of the same wavelength at the same temperature. Evidence for the existence of energy level in an atom. The following are evidences that support the existence of energy level in atom. 1. Frank Hertz experiment. The experiment performed by Frank Hertz shows that energy level exists in atom. 2. Line spectra of the hydrogen gas. 3. Emission and absorption spectra. 4. Characteristic radiation of energy quanta emitted by Earth bodies. 5. Photoelectric emission. Photoelectric emission. Photoelectric emission. Before I will call it a day on this topic, let us run through what we have done so far. We started with energy level in atom. You were told that electrons can only occupy certain allowed energy levels in an atom. And because only certain energy levels are allowed, we say the energy is quantized. And when an electron jumped from a higher energy level to a lower energy level, an emission of photon is experienced. And this emission is given by the equation HF is equal to the difference between the two energy levels. And when an electron jumps from a lower energy level to a higher energy level, there is an absorption of photon. It is only when the electron absorbs photon energy, it can now jump from a lower to a higher energy level, which is also given by the equation HF is equal to the difference between the two energy levels. Then we were told when the electron is in the lowest possible energy level in an atom, it is said to be in ground state. And when an electron occupies an energy level where the energy is higher than what it can occupy, then we say it is in an excited state. And in order for it to return to the ground state, photon of energy must be emitted. Then we talk about emission spectra and absorption spectra. And emission spectra of three types: the line spectra, band spectra, and continuous spectra. Then we also quickly run through the evidences that are in support of existence of energy level in atom. The evidences are Frank X experiment, line spectra of hydrogen gas, emission and absorption spectra, then characteristic radiation of energy quanta emitted by Earth bodies, then photoelectric emission. This is where we are going to end the period for this week. Until next week when I will come your way again, my name is Oladimeji T.A., your physics teacher. The questions on the topic will be uploaded on the school portal. The students are advised to go and log in onto the school portal and go through the questions and submit the answers at the appropriate place on the school portal on or before the deadline that will be stipulated on the assignment. Until next week when I will come your way again, Assalamu alaikum wa rahmatullahi wa barakatuh.